Mr. João Barreto.
Good afternoon. My name is João Barreto. I am Director of Technology at Semco. And I have the pleasure to show you a presentation about a special development for a large agitator of a pulping tank in the process of decommission of tailing dam. In order to have the best solution, we not use only analytical calculation, but also CFD simulations. Semco is a Brazilian company with more than 65 years, providing solutions and equipments for many industries, with a very special expertise in mixing and agitation. Here is our portfolio of products, and for many other informations, see our website. Well, Brazil is a huge mining mineral country, and over the last decades, 100 of tailing dams were implemented. In order to avoid accidents, our government are pushing all the mining companies to eliminate most of these dams. Many of these dams are huge, with more than 50 million cubic meters of tailing dams and storage during the last decades. The solids are not homogeneous, not stable, and with a complex rheology and size distribution. To do this, it's necessary to drain the tailing and disposing solids under safe conditions and reusing the water for the process. One of the common solutions to drain tailing is to have a dredge inside the lagoon, pumping the slurry to a large tank with volume between 3,000 to 6,000 cubic meters. The first challenge is not to add more water in the process, so the tailing slurry must have a much solid concentration as possible. Because of this, the design of the repulping tank goes to a large diameter and a small cylindrical height, under to the keeper pressure on the ground of the acceptable number. In other words, we have agitation challenge is to guarantee homogeneity with maximum dead volume in a very complex rheology. The low consumption is another important goal to meet complex CAPEX and OPEX restriction and the green and ASG philosophy. A traditional agitator, the approach goes to a common large impeller diameter, and this kind of agitator has a very disadvantage, like high power consumption, a small pumping rate, and the strong loads to be supported by the shaft and the drive. Narrow blades do not work well positioned close to the bottom. And also, it's not the best solution for high concentration solids in the slurry. With our customer, we define some premises. The agitator have to guarantee a dead volume lower than 20%. The operator is to work with a high solid concentration and design to a designing factor of 20%. Pursue a reduction on the energy consumption of 25% is another important goal. Repulping the slurry with maximum homogeneity in order to guarantee a perfect pipeline operation. To reach these premises, We use our R&D department using CFD considering multiphasic parameters, also our lab test, and our especially strong experience supplying real agitators for many pipelining stations. Developing this kind of agitator, we use field informations that we could find in a project that we have for these applications, and we feed our CFD for a sequence of analysis. And we could find the best solution. 2 impellers, 1 wide blade, especially designed to operate close to the bottom, and a large high-performance impeller in the upper position. Optimal streamlines distribution inside the tank, even with varied volume. A very small dead volume, a reasonable low power consumption, and also with the streamlines velocity and acceleration, we could guarantee an operation with more than 70% of concentration. This is a real example in a huge tank of 5,800 cubic meters. And this is iron ore tailing. And you can see the results where we have a very better solution. This is the CFD simulation. You see that in the bottom of the tank, we have strong velocities around 0.75 meters per second, which is imperative to guarantee not solid settling in the bottom. Here we have a film showing the streamlines inside the vessel, when it's possible to see that most of the lines have a very strong velocity inside the vessel. This is like a tomography of the velocity vectors, where it's possible to see that we have most of the tank with 0.75 meters per second. In conclusion, we are saving 50% of power consumption. This is energy consumption. We are saving more than 7% of water. We have just only 15% of dead volume, and we have 25% less wearing due to the shear rate is less than the traditional construction. Probably we are 25% less cost in investment when we are comparing with the traditional solution. I'd like to thank the PDAC organizers and the audience for the opportunity to show some developments done in Brazil. And if you have any doubts or inquiry, do not hesitate in contact us. Thank you.